What are you doing right now? Are you watching this video? Most likely, you are sitting somewhere. Well, even though at this moment you may be motionless on the surface of the Earth itself is racing through space at a speed of about 30 kilometers per second. Similarly, the Sun, our entire solar system, and all of us are moving at a speed of approximately 220 kilometers per second around the center of our Milky Way galaxy. Of course, we do not feel any of these speeds on ourselves because gravity keeps us grounded during this high-speed journey. In the universe, everything is moving somewhere, nothing stands still in space. But what sets in motion this entire cosmic mechanism? The incessant universal movement is one of the most intriguing mysteries of astronomy. Since you started watching this video, and before you finish watching it, everything in the universe, including the Milky Way and the local group of galaxies, will have traveled hundreds of thousands of kilometers through space towards a mysterious gravitational center. Whatever is there, it exerts a remarkable, mysterious influence on the vast spaces around it. This is the Great Attractor. The Milky Way is an ancient galaxy that is home to hundreds of billions of stars. But there are hundreds of billions, if not trillions, of such galaxies in the universe, many of which are much larger and more densely populated with stars than our own galaxy. And when such a multitude of stars come together, gravity allows them to work with a stronger gravitational influence. Galaxies are incredibly massive objects that can attract each other over distances of millions of light years, sometimes approaching so closely that it leads to a collision. However, the space between galaxies is much larger than the galaxies themselves, and here another force, known as Hubble's law, describing the expansion of the universe, comes into play. According to this law postulated by Hubble, galaxies are mostly uniformly moving away from each other as the universe expands. Therefore, many galaxies are at a significant distance from their cosmic neighbors to avoid collision. Only small, localized areas of space, such as our local group, are dense enough clusters to be squeezed by gravity into a single structure. However, although many of these galaxies are not destined to collide, dense clusters of galaxies can still influence each other to the extent that their combined gravitational potential attracts more distant galaxies, creating denser clusters and emptying the space between them. Actually, this forms a comprehensive structure that extends throughout the universe like a cosmic spiderweb, with branching regions in all directions. This cosmic spiderweb consists of vast interacting walls of galaxies known as galactic filaments, which can contain hundreds of thousands of galaxies and stretch for billions of light years. Galaxies within these filaments migrate along paths within the structure, converging and diverging like great cosmic rivers flowing across unimaginable distances, forming individual components known as galaxy clusters and superclusters. These are mostly small groups of dozens to hundreds, or possibly even thousands, of galaxies that are more concentrated than the density of the filaments. In fact, the boundaries between clusters, superclusters, and filaments are somewhat blurry, primarily because we did not realize that galactic structures the size of a fiber could exist and interact at distances of billions of light years. And this was a mistake. Over the last 40 years, astronomers have managed to create a comprehensive three-dimensional map of intergalactic space. Using this map, we have learned much about our large-scale environment, which is not bad for a tiny world whose lifespan is fleeting on the galactic timescale. We know that our local group, which includes us, the Andromeda Galaxy, the Triangulum Galaxy, and more than 100 other small satellite galaxies, is located in a relatively distant region compared to the cluster of more than 1,300 galaxies known as the Virgo cluster. This cluster is the gravitational center of a much larger colony consisting of more than 100 groups of galaxies known as the Virgo supercluster, one of approximately 10 million superclusters of galaxies in the observable universe. The Virgo supercluster extends over an area of more than 110 million light-years and is believed to be more than 7,000 times more massive than our local group, which is sufficient to exert significant influence on neighboring intergalactic space. But the cluster network does not end there. The study by astronomers from the University of Hawaii, published in 2014, showed that the Virgo supercluster is just a part of an even larger supercluster, called Laniakea. This supercluster extends approximately 520 million light-years and is home to more than 100,000 galaxies. Laniakea is so massive that astronomers did not realize for a long time that its constituent superclusters were connected to each other. Laniakea consists of 4 main galactic superclusters: our own Virgo supercluster, which includes our local group containing the Milky Way galaxy and the solar system, the Hydra Centaurus supercluster, the Pavoendus supercluster, and the Southern supercluster. Despite their huge cosmic distances from each other, they are connected, creating a multitude of streams in space. All these streams move in one direction towards a gravitational anomaly of enormous strength, which binds all the clusters together in an area of 500 million light-years. This anomaly is what we mean when we say the Great Attractor. The Great Attractor is the name given to a gravitational anomaly located in the supercluster of galaxies called the Laniakea, which is believed to be about 250 million light-years away from us. This anomaly is what attracts all clusters and superclusters of galaxies, including our home galaxy, the Milky Way, along with us. Everything within hundreds of millions of light-years is drawn towards this area, which can only mean one of two things. Either there is an extraordinarily high concentration of mass there, such as a supermassive or very dense gravitational cluster, or there is something stranger, like an intergalactic black hole. Alternatively, a mysterious dark force opposing the expansion of the universe may be located there. But whatever it is, it creates one fundamental problem, namely, we don't know what it is. In addition to the nature of the source itself, the location of the Great Attractor is a mystery. It is located in a region of the sky that is obscured by the galactic plane of the Milky Way when observed from Earth. Because our solar system is located between two spiral arms of our galaxy and its bright core and dust clouds obscure about 1/5 of our field of view, this area is known as the zone of avoidance, making it nearly impossible to observe or detect anything within or beyond it. It will take approximately 100 million years for the solar system to move us to the other side of the Milky Way, where a different view of the universe will be revealed. However, for now, the biggest gravitational anomaly continues to attract us while remaining a hidden area. The first signs of the Great Attractor were discovered in the 1970s. At that time, technology did not allow scientists to peer beyond the wall of dust and see what was beyond the zone of avoidance. It was only when scientists began to create the first detailed maps of the cosmic microwave background that they discovered the so-called relic dipole radiation, a temperature gradient. It was then that scientists realized that this mismatch was the result of the Milky Way's motion in space and its movement towards the red region. When scientists tried to measure our peculiar velocity by tracking the Sun relative to the relic radiation, they found that we were moving towards the constellation Centaurus at a speed of about 600 kilometers per second. And this turned out to be no coincidence. Something in this area is attracting us, but no matter where we go, it is beyond the zone of avoidance. For decades, the reason for such an unusual speed remained a subject of discussion and various speculations. However, times have changed and technological progress has taken a significant step forward. Now, we are no longer limited to observing visible light. Although the plane of the Milky Way still does not allow light that we could see beyond our galaxy. Now we have electromagnetic and X-ray radiation, which can penetrate through clouds of dust, allowing us to see what is beyond the avoidance zone. For example, the best way to look beyond the avoidance zone is X-rays. X-rays are a type of electromagnetic radiation that can penetrate through dust clouds that obstruct the view in the optical range. Thus, in 1996, using data from the Rosat microwave probe, a group of researchers led by South African astrophysicist René Kraan-Kortweg discovered evidence of galaxy clusters in the avoidance zone that were previously impossible to detect, but now are considered a key galactic cluster at the heart of the Great Attractor. The Norma cluster is located about 220 million light-years away from us and is considered very close to the Great Attractor. Some scientists speculate that the Great Attractor is likely a supercluster called Abell 3627, as it is located near its core. But either way, the Norma cluster still doesn't provide a complete picture. Despite being quite massive, its mass is not enough to explain the peculiar velocity of the Milky Way. Researchers say that if the mass of the Norma cluster is not sufficient, then there must be something else there. And although many scientists agree that the Great Attractor is the result of a dense concentration of galaxies, it is by no means the only theory. There are also those who refute the idea of the supercluster's responsibility for the unmatched scale of its influence compared to other cosmic structures. As it is believed that the expansion of the universe is caused and accelerated by a phenomenon known as dark energy, there are those who speculate that only something similar, dark and otherworldly, could be at the heart of the Great Attractor. This leads us to alternative explanations for the Great Attractor. The idea that some mysterious and unknown force is responsible for the bulk flows of galaxies that we see in the Laniakea supercluster has been dubbed the dark flow, which is what causes galaxies to move towards a single point instead of moving away from each other. And if this is true, then according to astrophysicists' assumptions, there may be a structure on the other side of the Great Attractor that, conversely, repels galaxies, called the dipole repeller. Just as all galaxies in the Laniakea supercluster flow towards the Great Attractor and, on the opposite side, they flow out of this region, as if something is repelling them. Perhaps the Great Attractor and the dipole repeller are part of the cosmic flow of galaxies in the universe. In fact, the Great Attractor is not as great as astronomers previously thought. Although this focal point of the Laniakea supercluster, which is drawing us towards it, is not the only thing influencing the Milky Way. New research has revealed a significant concentration of galaxies much farther away from the Great Attractor, near the Shapley supercluster. The Shapley supercluster is located about 650 million light-years away from us, and although it was discovered in the 1930s by American astronomer Harlow Shapley, researchers only became interested in it with the advent of more modern technologies. In 2005, astronomers discovered a concentration of galaxies near the Shapley supercluster, dubbed the Shapley Attractor, which turned out to be an even larger and more massive galactic density than the Great Attractor. In total, the Shapley supercluster is home to more than 8,000 galaxies and has a mass about 10,000 times greater than the Milky Way, which is 4 times greater than the mass observed in the vicinity of the Great Attractor. It has been found that this supercluster is what contributes the majority of the influence responsible for the peculiar velocity of the Milky Way. While our cluster is moving towards the Great Attractor itself is being pulled towards the Shapley supercluster. Astronomers have determined that our peculiar velocity is the result of a complex effect where the Great Attractor is responsible for approximately 44% of the motion and is closer to us. The remaining 56% of the velocity is linked to the more massive and distant Shapley supercluster, which is dragging the Great Attractor and consequently the galaxies in our cluster along with it. But there was one more part of the mystery yet to be revealed. When the Shapley Attractor was identified, astronomers speculated that there might be another, more distant galaxy supercluster that also contributes to our perception of motion in space. And just 5 years ago, a team of astronomers who discovered the Norma supercluster almost 20 years ago were able to solve the mystery they had been working on for nearly 2 decades. In 2016, they announced the discovery of a new supercluster in the zone of avoidance, located further than the Shapley supercluster. Using data from the Australian and South African Large Telescope, they identified the region of superdensity corresponding to the galactic supercluster at a distance of about 800 million light-years. This galactic supercluster, named the Pavoindus supercluster, is the final piece of the puzzle that, as is believed, contributes to our peculiar velocity. Now, thanks to the influence of the Norma cluster, the Shapley Attractor, and a little help from the Vela supercluster, we can finally explain the observed effects of the Great Attractor, which were noticed many years ago and made it so mysterious. Well, the universe still holds many different secrets and cosmic books for us and our descendants to unravel. That's all from me for today. Leave your comments, give likes, and if you enjoyed the video, share it with your friends. And also, take care of yourselves and your loved ones. A huge thank you to everyone who supported me. Wishing you all the very best, dear friends. Until our next, even more interesting cosmic encounter.